Next up, y equals x squared minus 5x plus 9, and y equals 8 minus x. So we'll substitute x squared minus 5x plus 9 in for y. So we have x squared minus 5x plus 9 equals 8 minus x by substitution. We have a quadratic equation, need that equal to 0. So we'll add x to both sides, so that will make it minus 4x. Subtract 8 from both sides, that will make it plus 1. Well, just looking at this quadratic, it's not going to be factorable. So in order to solve this, we have to use the quadratic formula. So a is 1, b is negative 4, c is 1, so our discriminant is b squared minus 4ac, so b squared minus 4ac, so that's 16 minus 4, which is 12. So that does confirm that we can't factor this, but we can definitely solve it. It's not a negative discriminant, so we can use our quadratic formula. So x equals negative b plus or minus the square root of the discriminant all over 2a. So the square root of 12 can be simplified to the square root of 4 times the square root of 3, which is 2 times the square root of 3. So simplifying, negative 4 is positive 4, plus or minus 2 times the square root of 3 all over 2. In the numerator, we can factor out a 2. 2 plus or minus the square root of 3 over 2. The 2 in the numerator and the denominator simplify. And we have x equals 2 plus or minus the square root of 3. Okay, so that means we have either x equals 2 plus the square root of 3 or x equals 2 minus the square root of 3. Now remember, we still have to find those y values. And y equals 8 minus x. So here y equals 8 minus, in parentheses, 2 plus the square root of 3. So y equals 8 minus 2 minus the square root of 3. So y equals 6 minus the square root of 3. And then for our other x value, we have y equals 8 minus, in parentheses, 2 minus the square root of 3. So y equals 8 minus 2 plus the square root of 3, which is y equals 6 plus the square root of 3. So our 2 points of intersection look a little bit more complex here. So that's 2 plus the square root of 3, comma 6 minus the square root of 3, and 2 minus the square root of 3, comma 6 plus the square root of 3. So there are our 2 points of intersection, and this is an example that definitely would be impossible to solve graphically. The only way we're coming up with these 2 points of intersection is algebraically, which is why we have to go over both methods, right? Algebraically will always work. Graphically, if the points are nice, we'll be able to find them. And it's nice to also visualize what this system of equations look like. Okay. Our last example, determine the number of points of intersection between y equals 2x squared plus 15x minus 6 and y equals negative 2x plus 3 by using the discriminant of the quadratic created in solving. Okay, so let's take a step back for a second. They're not asking for the actual points of intersection. They just want to know the number of points. How many? And then it says using the discriminant of the quadratic created in solving. Okay, so they don't want the discriminant of this quadratic. They want it when I'm solving. So let's start solving and see if we get to the point where this makes sense. So we'll solve by substitution. So we'll substitute 2x squared plus 15x minus 6 in for y. So we have 2x squared plus 15x minus 6 equals negative 2x plus 3. So we have a quadratic equation we're trying to solve, so we'll set it equal to 0. So we have 2x squared, we'll add 2x on both sides, so plus 17x, and subtract 3 on both sides, so minus 9 equals 0. Well, this is the quadratic that I'm trying to solve in order to come up with the solutions to the system of equations. So the problem wants me to find the discriminant of this quadratic. Okay, so the discriminant is b squared, so 17 squared minus 4 times a times c. So let's see, let's use the calculator here. 17 squared, 289. So we have 289, and then plus 4 times 2 is 8, times 9 is 72. So we can go back to the calculator here. 289 plus 72, that's 361. Okay, so the discriminant is positive. So when we had a positive discriminant, we had unequal solutions, which means there's two of them. Well, if there's two solutions in the quadratic formula, that means we're going to have 2 points of intersection. Okay, so we have 2 points of intersection. So essentially what this question is asking us to do is go back to that nature of the roots. And it's tying in the nature of the roots to solving a system, a linear quadratic system of equations algebraically. So we start solving, we get a quadratic that we would find the discriminant of in order to solve. And here they don't actually want the solutions, they just want to know how many solutions are we going to have. So the fact that we have a positive discriminant, right, back to the nature of roots, we would describe the roots of this quadratic, 2x squared plus 17x minus 9, not a quadratic we're graphing. We would describe the roots as real, rational, unequal. Unequal is the important part because that means there's 2 solutions to this equation, which means we'll have 2 points of intersection. Okay, so just to quickly recap what we did in this video, we solved linear quadratic systems of equations algebraically, whether that was by factoring or with the quadratic formula. And then we saw 3 different cases. Systems where there was 2 points of intersection, systems where there was 1 point of intersection, and systems where there were no point of intersection or no solution. Okay, so go practice your algebraic skills of solving and also working on these linear quadratic systems of equations. Click the Amazon link down below for my algebra workbook so you can practice on your own. Give the video a like, and before you go, click that subscribe button so you can see more videos just like this. Thanks for watching.